Greetings. This is a testimonial video about the experience that I achieved during my internship inside the Universidad de Concepción. The title of my project is the development of an automated platform for efficient energy management in Universidad de Concepción. From this part, Universidad de Concepción will be abbreviated as UDEC. My name is BrandonZarate and I'm studying mechatronics engineering in the Universidad de las Américas Puebla. The description of my project is the next. This project seeks to develop a monitoring platform whose functions allow us to continue with the process of continuous improvement in terms of energy efficiency inside UDEC buildings. Last semester, I've already developed a first project that was focused in energy efficiency. So this is the second part of it. This work intends to develop and integrate different engineering areas to generate a software that adheres to the ISO 50001 standard, and it would fit into the context of the development of smart cities. The developed prototypes during this project are parts of an AP with cloud computer structure. Its service is oriented as a PaaS, Platform as a Service, to provide users with an application, platforms, and database as a service. The main objective of myself during the execution of this professional practice was the creation of an automated monitoring platform, which will receive constant information from more than 50 smart meters that are installed inside different electrical substations, and those substations are also inside different buildings of the UDEC. That software is tended to be capable of entering and analyzing the information of all of the measured physical quantities and electrical quantities, so that several users can identify opportunities of improvement. Those users are realized as members of the maintenance department and the electrical engineering department. So the main goal here is that the presentation of the information should be friendly to those users managing and synthesizing the data to generate graphic tendencies to improve planning and decision making, oriented towards to the reduction of the expenditure of electrical energy. For this project, 7 goals were planned to achieve the main objective of this project. The first one is the collection of information about the libraries needed for the project. At first instance, it was planned that every step of the platform programming would be made inside Python. But during this and other future investigations, I've decided that I should integrate other programming language. So the second step is bibliographic review of similar applications in the national and international market. During this review, I also made other techniques to support and justify the implementation of this project. The third step the third step was the first tests, and those were related to data reception from the smart meter and database generation. The fourth step was achieving parallelism of operations for the other equipment in the monitoring network. So in the prototype phase, I've iterate the code simulating that I'm measuring several smart meters at the same time. Then the fifth step is the generation of graphs and application of formulas for data processing. The sixth step was the design of an interface using Android Studio, and the last one was the compilation and proof of errors, as well as debugging the code. While this part, the seventh step, was thought in the general way, but every code that I've sent to my teachers and project manager have no errors. Well, now I'm going to talk about the technical specification of my project. The first one is that the application should obtain relevant data at size thanks to the reliable and continuous recording of the already installed smart meters in the electrical substation. These meters can measure voltage, current, THD, active, reactive, and apparent powers, and several others electrical quantities. Those sensors are connected to analyze each of the three phases and the neutral part. So I must manage 4 different entries for each of the smart meter. For each smart meter. Then the next specification is that all of the historical data should be reported and have enough backup to store at least 5 years. Why this much of information? Because with this, people can make decisions having a better historical reports. And those reports must be portable and configurable by the user that is exporting the desired data. The next specification is about, again, the parallelism of the program. And in this case, it should make parallel registration of operational data and equipment. The next specification is that the platform should give us the status of the monitoring, because all of the smart meters can record different type of errors. So this platform should deliver a notification or an alert to advise the user or to show the user that there is an error in the network. The next one is that the graphical representation of the data should be easily to identify every point of the or every measuring point through time. And also the user should identify all of the characteristics in the energy demand that are wasting their resources. So with this graphical data, the user should simplify their work. And the last one is that the software is based in the ISO 50001 regulation, because it is specifically related to energy management systems. The regulations studied and take out in consideration for this project were mainly two. They already talked about the ISO 5001 regulation about energy management systems, and this standard is based in a continuous improvement plan. So this plan is the Plan, Do, Check, Act form that is intrinsic in a lot of business, and this continual improvement framework incorporates energy management into existing organizational practice. So the use of the platform is idealized as an activity of the departments that will have it. The second regulation is the Decree 11 of the Ministry of Energy in Chile. This fixes the tariff formulas applicable to liable supplies to regulate prices made by the distribution concession companies. Now I will talk about the contributions that I made to this project. Well, all of the parts of this project was implemented by me, so I will explain only the AP model for resource states. So at first time, the smart meters are sending the information via the Modbus TCP protocol, and they send that data to a router. Those meters are already configured with an IP direction, a gateway, and a mask. Then from the router, the Python socket is connected and listening to all of and asking for specific registers in the data memory, because in those specific registers are labeled already for and assigned for an electrical variable. So if I want, I don't know, the instant current in phase 1, I should listen to register 5512, for example. That's a real example. Then from that Python socket, all of the information is sent to MySQL MySQL database, and are filling constantly that table. The next step is that a web service page programmed using PHP is the one that manage and fetch the data inside MySQL. And that web service also fits all of the queue requests made by the Android Studio part, or made by the user in this case. So that's the entire model of this AP. And then I will talk about all of the learning that I've made during this internship. The first one is that I've learned how to integrate. I integrate myself in this application development, and this is right now something mainstream and something that all companies are making. So it's a good point inside my curriculum. Then in my knowledge, I expanded my knowledge about the use of programming languages, because I've never programmed in Java for Android Studio in this case. I've never programmed in PHP, and I've also never programmed using MySQL database. Because I am a mechatronic engineer, I have reduced knowledge about computing programming language and data structures and manipulation of databases, and I have lack of those parts. So during this project, I've learned a lot about it. Then the management of databases, well, I've already explained it. Also, I've learned about the tariff regulations and international standard for the management of energy systems, because one of my plans in life right now is to work in management of energy system. So the development of this application would be important during my professional life. And at last, I've learned about the integration of information technologies in traditional electrical system as part of the fourth industrial revolutions. Well, right now I will talk about my conclusions. And well, I can conclude that today there are many facilities by private software companies so that application developers can create unique environments thanks to their open source development platforms. All the language described inside my project have a way to work together. Then, so knowing how to connect between them, well, is crucial. Then open projects of like PHP, like Android Studio, help in the economic part of the development of application, reducing the impact to cost of the development part. The only cost that I have, or I will present to the people of the universities that launching the application into the Google Store cost $25. And the other one is that if they want me to continue using Firebase database, that database or that service is limited to 20,000 ratings inside of it. So, for example, if I have 50 smart meters connected, recording data every second, well, making the calculation, in an hour I will have more than 3,600 of data written. So I will fill of all of the 20,000 writing in just a couple of hours. So that's the other implication. I'm using right now MySQL to save that cost, but it's relatively cheap to produce this application. And the last conclusion that I could make is that all of the skills that I've developed during this project expanded my knowledge of programming language and all of the methodology that is intrinsic during this process, because I already said that I am a mechatronical engineer, so building an application is not common for me. I've developed a small application for microchips and are only in C language or in assembly language, but not in high level programming. So all of the skills of integrating, I have the base for integration, but not using high level programming language. So it was like a test for me. So I'm concluding all of this expertise during my internship. Thank you.